Two measurements, same universe, both verified, incompatible. The standard model of cosmology is cracking. Dataset by dataset, instrument by instrument, cracking. The gravity matrix. Two teams measure the universe's expansion rate. Here at the gravity matrix, we track every major dataset. One team measures 73 kilometers per second per megaparsec. The other measures 67. Both are verified, both confirmed. That gap is 5 sigma, not random noise. Something fundamental is wrong with our cosmological model. To understand why, we need Einstein's greatest blunder. In 1917, Einstein needed a static universe. He added lambda, a repulsive energy fighting gravity. 12 years later, Hubble discovered the universe expands. Einstein called lambda his greatest blunder. He withdrew it. For 60 years, the universe was gravity versus expansion. Then 1998 changed everything. Supernovae said it speeds up. Lambda returned as dark energy. The blunder was right. Riess Schmidt, Perlmutter won the 2011 Nobel Prize for this. Lambdictum became the standard model, 30 years of certainty. Planck satellite confirmed it in 2013. H0 equals 67.4. But ground-based teams kept measuring 73 every time. Both measurements verified, both confirmed, impossible to reconcile. Adame Riess at Johns Hopkins spent years ruling out errors. He wrote, "Perhaps we have misunderstood the universe." Wendy Friedman's team proposed a third measurement path. Her Hubble constant landed between 67 and 73, suspiciously. The tension reached 5 sigma, the gold standard in physics. Less than one chance in 3.5 million. If this is noise, it is the most unlucky coincidence. If not noise, something new is happening in spacetime. Enter DESI, the dark energy spectroscopic instrument. It sees 50 galaxy spectra simultaneously, every night. Its mission, map the universe in 3 dimensions. Baryon acoustic oscillations, sound waves from the Big Bang. These waves left imprints in galaxy distribution, a cosmic ruler. DESI measures this ruler at different cosmic epochs. If dark energy is constant, the ruler's evolution is predictable. DESI's 2024 first release hinted at something unexpected. Dark energy's equation of state might not equal -1. In physics terms, lambda might be changing with time. That means our best cosmological model could be wrong. Will Percival at Waterloo described it as deeply unsettling. The 2024 results covered only the first survey year. March 2025, DESI DR2, 3 years, 15 million galaxies. The significance for evolving dark energy, 42 sigma. Not a discovery, but the strongest signal in cosmology today. Combined with Planck's CMB, JWST, and supernovae data, the W0 parameterization reveals something deeply troubling. Dark energy's equation of state may cross the phantom divide. Standard scalar field models cannot cross that boundary. If real, it requires entirely new physics beyond Einstein. Here is what we find most striking about this result. 3 independent methods all show the same deviation. That is not noise, that is a signal worth scrutiny. We have been tracking this dataset since the preliminary results. What changed when JWST entered the picture? JWST was supposed to resolve the Hubble tension definitively. Its NIR-CAM detected Cepheids more precisely than Hubble. The result came back, 73 kilometers per second per megaparsec. Riess ruled out dust and crowding as explanations. The tension did not go away, it hardened into crisis. JWST was also finding unexpected objects in the early universe. Galaxies too massive for their age, twice the expected count. Some turned out to be active galactic nuclei, AGN. But the excess remains, twice the galaxies even after corrections. Stars may have formed faster in the early universe. Here is the question that keeps cosmologists up at night. If both JWST and DESI are right, what breaks first? Does dark energy evolve, or is our measurement framework broken? Both possibilities are genuinely terrifying for modern physics. In March 2025, the Berkeley Lab collaboration went quiet. DESI DR2, 4 to sigma, dark energy may be changing. Nearly 500 news articles appeared in 67 countries. Social engagement, 191 zero reactions, 6 times last year. Alexei Liu thawed, and Will Percival spoke with measured urgency. We may need to modify our standard cosmological model. This is what the data shows. The interpretation remains open. DESI alone mapped 15 million galaxies and quasars, tracking dark energy's influence across 11 billion years. The Baryon acoustic oscillation signal, clear and consistent. What the bow scale evolution showed shocked the collaboration. The standard model says lambda never changes. DESI disagrees. And Euclid's first data release arrived the same month. Euclid cone, 26 million galaxies, 500 new gravitational lenses. Euclid called it a goldmine for dark matter research. Primary cosmological results arrive in October 2026. If Euclid confirms DESI, the lambdictum model effectively collapses. If Euclid contradicts DESI, a different crisis begins. Year 4 of DESI's 5-year survey, the signal grows. Now we need to understand what phantom crossing actually means. Standard dark energy, called quintessence, stays above -1. Phantom dark energy crosses below -1, physics violation. It would violate the null energy condition, fundamental physics. Phantom crossing means the universe crosses between regimes. DESI's best fit model crosses W equals -1 twice. For 25 years, we assumed the universe would expand forever. Dark energy pushes everything apart, eternal acceleration, heat death. But phantom dark energy can reverse, its density can grow. If dark energy weakens enough, gravity takes over again. The universe could contract, a big crunch scenario. In February 2026, new papers calculated the crunch timeline. If DESI's equation of state is right, fate changes. This is not established physics. The data makes it possible. We must say so explicitly. This is pre-5 sigma territory. The error bars still allow lambdictum to technically survive. But just barely, and those error bars keep shrinking. The Red H0T initiative now stress tests the Hubble constant methods. The European Research Council funded a red team approach. If Red H0T finds nothing, the crisis deepens irreversibly. The 2025 Corfu Conference, 130 researchers, no consensus. They came from Planck, DESI, JWST, Euclid, no agreement. But disagreement here is not failure. This is physics working. Every crack in lambdictum opens a window into the unknown. Consider what the dark energy saga actually reveals about science. Einstein added lambda for wrong reasons. The universe expands. Yet lambda became the most precisely confirmed cosmological feature. Now DESI hints it might change. The irony runs deep. We may be living through the most exciting era yet. Since Hubble first proved the universe was expanding, 1923. Here is what to watch. Our framework moment begins. October 2026. Euclid delivers primary cosmological results. If Euclid confirms DESI, that is the new physics. If it contradicts DESI, the systematic errors become the story. Watch the W0 plane. Does lambda stay inside the contour? Watch whether the Hubble tension reaches 5 sigma or retreats. Watch the red H0T results for hidden systematic errors found. The next 12 months may rewrite or confirm the textbooks. Either way, we will be watching every dataset released. Step back from the numbers, from sigma levels and equations. Consider what 68 of the universe being unknown actually means. Every atom, every star, every planet, every life, 5%. We built the most precise cosmological model from 5%. And now the other 68% is refusing to stay quiet. Dark energy refuses to be a constant in our equations. It is telling us something. DESI is learning its language. We may watch modern cosmology crack open in our lifetimes. Not as failure, as the most exciting cosmological moment. Since 1998, when supernovae first shocked the physics community. This is what science is supposed to do. The iron in your blood was forged in dying stars. The calcium in your bones came from ancient stellar explosions. You are not separate from this universe investigating itself. You are the universe noticing its constants might be changing. Dark energy comprises 68 of everything. We barely understand it. DESI, JWST, and Euclid are the instruments changing that. The data is being collected right now, tonight, always. Looking at dark sky means looking through dark energy. We don't know what it is. That uncertainty is extraordinary. Physics doesn't care about our timelines or our comfort. It gave us instruments, curiosity, and the data to ask.